Okay, welcome back. In the previous video, we learned given the mass of an element, we needed to figure out how many atoms there is in a given element or how many atoms is there in a molecule given the mass of that compound or a molecule, right? In this particular case, we're going to learn the shortened version of what we learned previously. That is, say you're given grams, okay? And you're asked to find how many molecules is there. Well, essentially, your train doesn't go all the way to atoms. It's probably a late night service, so it doesn't go all the way, it just stops. A stop before its regular destination. So you're gonna start with grams, and then you're gonna do your molar mass conversion. And then, remember, we're dealing with molecules, so obviously, 1 mole is 6.022 e to the 23 molecules. And then we multiplied it by the number of elements to get the atoms. But again, as I said, this train's not going its entire journey. It's going to get cut off. 1 stop before its regular destination. So this sequence is exactly the same as the penultimate sequence I gave you. Only difference is this is just missing that extra step if your train doesn't want to go all the way, right? So let's calculate. In chemistry, it's always good to follow up a concept with a problem or some kind of practice so you actually understand the concept, right? So how many molecules, okay, are there in, say, 3.5 grams of sulfuric acid? Okay, H2SO4. So first, as I said, you got to figure out what is that the question asks you to calculate and what is given. Grams given, molecules you're asked to find, so we use the sequence right here. So, but before that, we have to actually figure out the molar mass of sulfuric acid, all right? And I don't want to spend a lot of time teaching you again molar mass. I've taught you that enough in the previous videos, so I'm going to go straight to the chase. So sulfuric acid's molar mass is 98 grams per mole, or grams per 1 mole. Okay, you're wondering how I got it, do the math and you'll get it. All right, so 98 grams per mole. So we know the molar mass, we know the second conversion factor. Now it's just about putting everything together. All right, so let's go get a different color. As I said, you always start with the given information for which I put a check mark, and you don't just write number or unit, you write everything. So you write the quantity, the unit, and the substance, right? And then write 1 underneath it because there's no information available. All right, what's the next information do we need? Okay, we need to go from grams to molecules through molar mass and then mole to molecule conversion. But first we got to get rid of the grams, for which we're going to use the molar mass, and it's 98 grams per mole. 98 gram goes on the bottom, 1 mole goes on the top, right? Because we have to cancel out our grams, right? Okay, that's good. Now we're left with moles. Now we got to get rid of the moles to go to molecules, and we use this conversion factor. A mole of sulfuric acid should contain 6.022 e to the 23 molecules. That's the conversion, right? Right? So what does that give us? That's the final step to get to our answer. So it'll be 3.5 by 98. 3.5 by 98, and then multiplied by 6.022 exponential 23. What does that give us? That gives us a 2.15 e to the 22 molecules. Okay, let's get a different color. That's our answer. That's how many molecules are contained in. It's the way it's written. You think, well, I already know there's only one H2SO4. No, that one H2SO4 is just the formula of what quantity you're starting with. So if you're going to start with 3.5 grams of sulfuric acid, if you're going to weigh this in, then you're going to contain that many of that. So you're going to have 2.5 e to the 22 molecules. You don't just have one H2SO4, you have that many of it. Okay? So that's what we're really trying to understand here. Now, something I have not told you, but I guess you can backtrack it. We can maybe do one problem out of the 3 sequences I have given you. Is we've always started from grams, went to atoms in an element, atoms in a molecule, and then grams to molecules. But we didn't do the backwards, but that's not all that difficult. But we can certainly have a practice of one of them, right? So actually, you know, we'll just do this. Okay. So let's say you have, I don't really see why somebody would do this calculation other than really for the purpose of a chemistry class. I don't think anybody would have this information available to them at any point of time, because you cannot really calculate how many atoms you have. But, you know, this is really to understand and drive the concept across, right? So let's say you have, let's write the question slightly different. How many atoms of nitrogen are there, or sorry, how many actually grams of nitrogen are there in, see, it's natural for me to not write grams but atoms. So are there in, say, 2.5 e to the 22 atoms. Okay, I don't know where this would become important to you other than a merely a test-taking area, because I don't think anybody can actually get 2.e22 atoms and then backtrack it to calculate the grams. Okay, that's usually not the case. I don't think you can do that in a lab, but you can do this on a piece of paper, just like we're going to do now. And again, what do we don't know? We don't know grams. And what do we know? We know atoms, right? So this is an element. You don't see any subscripts. You don't see any molecule. So what is the sequence? For grams to atoms, we're going to go through the molar mass, right? And then we're going to go through 1 mole is 6.022 e to the 23 atoms. And then that gave us the atoms. This is if you're starting with a single element, and that is exactly what we're doing. But this time around, the train is going to go backwards. So let's, well, you've gone from point A to point B. As I said, point B to point A is not so much importance in a lab. It's only important on a test or a piece of paper. So we're given atoms. So we're going to go to this point right here. And then we're going to go to this destination right here. And then we're going to end up at our grams. Okay, we're going to backtrack the calculations, right? All right, so how is that going to work? So you write always the given information. So 2.5 e to the 22 atoms. And as always, there's nothing to put here. So we're just going to put a 1. And what are we doing? We have atoms now, right? And this is the conversion factor, 1 mole. But we have atoms, so atoms got to go on the bottom. So 6.022 e to the 23 atoms, right? And then that is a mole, right? Because this is the conversion, but we're not going in the forward direction, we're going in the reverse direction, going back to our grams. So the atoms goes on the bottom, so we can now get rid of it. And a mole, well, we haven't determined nitrogen's, just the elemental molar mass is 14 grams over a mole. Now keep in mind, in the previous case, the gram went on the bottom. This time the gram's going to go on the top. Why? Because we have to get rid of the mole from our calculation. So 14 grams go on the top. So that's essentially what we are going to have to do. So that'll give us our answer, essentially. So let's do the math. So it's 2.5 e to the 22 divided by 6.022 exponential 23 times 14. So that's 0.58 grams. So do you see why, if you, right? Do you see this? Does the math make sense? Okay, 14 gram, okay, of nitrogen would contain 6.022 10 to the 23 atoms, right? But 0.58 grams only contains that much of it, right? So it's containing the less and less amount you take, the less and less number of atoms you will have, right? A mole contains, so many atoms make up 14 grams, right? But if you notice, if it's only 0.58 grams, the number of atoms is also less. That's the point I was trying to get across. But this is the sequence you're going to use if you're going to go back from atoms to grams. And I'm not going to do a problem for molecules to grams. That's essentially the same thing. You just have to backtrack the sequence. However, I can leave you all with a practice. So okay, so how many grams are there in 2.5 e to the 23 molecules of N2? Pay attention. The reason I'm not doing it is sometimes you got to figure it out and know what you don't understand, where you struggle. If I continue to work it out, you would always seem to think you're getting it, but you have to actually do this yourself to really figure it out, okay? So I would probably, likely, or maybe provide a solution to this problem in the next video. But if you don't understand it, you can ask me in class, and I would most likely create a video to answer this problem, okay? But for now, just practice. And if you have questions, ask me, and wait for this next video in this series. Stay tuned. Bye-bye.